Hey guys, welcome back to Seller Sessions, 4 p.m. on a Wednesday afternoon. So today I'm going to be talking about what happens with A9 when updates occur. I mean, we get a sweep across the industry in a lot of cases. And we had a big update, I think it was about 3 months ago now, where people reported on the weekend. So they see an algorithmic shift or there's a shuffle, etc. So what I wanted to do is just want to take a little look behind that and what happens in terms of how do these changes made and how are they pushed. I'm going to just allow for a few more people to enter, and then we'll get started. 1 second. And now getting repeat. In terms of how do these changes made and how all right. Changes made. Don't want to hear my voice in there twice. Right, yeah, we'll just wait for a couple more in the room. I'm just going to share to the groups and we shall get started. If anyone has any questions before I start, just let us know, put them into the comments, and we'll get going in a moment after I've done this share. 1 second. Okay. Okay. Nearly there. Cool. Right. Cool. Right. Let's get going. So again, I want to take this from the A9 literature. So I'll be quoting some stuff and I'll be mixing in some of my information, some of my feedback and observations, and hopefully be able to use this on a playback link through the podcast, etc., to make your own assumptions from this as well. So from the A9 literature, let's just kick off. So the idea behind the concept now is to have a look at when an algorithmic update is pushed, what is happening in the background. So to quote here, ranking models are responsible for a function that gives a customer's query, returns a sorted list of products in a match set. A single ranking model usually covers a combination of a category and marketplace, e.g. books in Japan. For training, the ranking models we use are labels based on customer actions such as purchases, add to basket, or clicks. So I mentioned before, if you listen back to one of the original shows I've done on A9, we talked about negative and positive labels. We also talked about a hunger score, and I think with the hunger score, this is something that I'll probably do more of a show on and break that out a bit further so people get more clarity on it. But it's quite clear with the negative and positive labels are a set of actions. So what Amazon is saying is it's just as important to understand what the customer is doing versus what they're not doing, so they can collect that data, which boils down to relevance. We use the search engine to collect our training set. Several times per day, we compute the unique set of keywords issued to each context of interest. The context can be a combination of marketplace category and some user features. Then we reissue these queries in the context requesting feature values for all items in a match set. So again, goes back to the point of when they push a rollout, they're designed a set behind it, and it has a number of features. I'll get into this in a minute. The feature collection runs regularly so that the feature vector collected is as close as possible to the one that is observed with the query for the original issued for the customers. Now, vectors are effectively a logical element in a programming language that is used for storing data. So they're storing this information and getting that together in order to project these training sets. So to train ranking models, we construct training, validation, and test sets by collecting data from several days of customer traffic. Test sets are constructed from data after the training set dates. We choose impressions that resulted in either a click or a purchase as a positive example, going back to the negative and the positive labels. These are two types of negative example: impressions, which are seen corresponding to items where they're displayed to the customer, and of course unseen, corresponding to items which were matched to the query in terms but were not shown to pagination. For those who don't know, paginations when they do next page, etc. So it's just capturing everything above the pagination fold, for a better word for it. So effective, again, what we're discussing here is relevancy in a nutshell. Amazon just wants to know just as much about negative information versus the positive information, because they can then weigh out their data sets. So it allows them the greater depth of knowledge when they're set, so they can actually serve better content in terms of the search results page. To manage the size of the training set, we use sample unseen examples. Gradient boosted trees, again, we're getting into the more technical jargon here, are a method of choosing the ranking because we can discover complex features, feature interactions, and can handle categorical and real valued features are robust in the presence of missing values. So gradient boosting is a machine learning technique for regression, classification, and other tasks, which produces a predictive model. So even if you don't understand that part there, just understand that this is something, it's a mechanism that allows for everything to be grouped together under a classification or regression, and it's presented as a prediction model overall. So for ranking problems, we use models trained with pairwise objects and NDCG as the default object function. We do feature selection in two stages. First, with fixed values of a tree depth and learning rate. We train, example, a kitchen sink model allowing for all features available. We then discard these features, which end up being ranked lower than random features, and use the remaining features to grow into the final set in the forward selection. So once a feature is chosen, we perform a grid search, a repair of values, again, more jargon, but finally the model is evaluated with an A/B test. So when they get past all the geeky speak there, and the final stage of that, of understanding this, is the variety of metrics they're looking for, and including two, is the number of converting customers, the number of products they purchase, and the overall revenue. So there's some key standouts with inside of their training sets, what they're looking to pull out against other information, but that's part of it there. So if we look at some of the behavioral aspects of what they're doing here, it says when training ranking models, we use many features. Some of them measure intrinsic properties of products, including sales and reviews. Others reflect properties of the queries or the context in which the query is issued. So query specificity and a customer status. Other features provide different measures of textual similarity. However, in product search, hundreds of products might share the very same descriptions and seem to be equally relevant to a particular query. But some of these products are more popular than others and should be ranked higher. That's why behavioral features drive Amazon search. And the last point I want to come across to here is blending across the categories. So ranking model provide rankings within categories, but customers often use the search all option on the search box. One of the biggest challenges in this case is to provide a blend of results from different categories. For example, for a query, Game of Thrones, customers may be looking for a book, TV, or a board game. The ordering of the results returned by any ranking model is not changed. What we do is that we therefore interleave results from individual categories based on an estimated of the probability of that query is being associated with a particular category. So what is kind of interesting here, we've seen that people have indexing issues as well. And one of those, if you think about it, if we're looking at everything on, rather than the broad search and on a category level, and we look at relevance, issues with index keywords are rooted to specific categories, but then perceived that there's a lack of relevance there for the ranking model, therefore you don't index, could be one of the reasons here. I actually got a last part here, which whilst everything seems to be bridged in one direction in terms of ranking, on the flip side, it seems like A9 is changed to accommodate from a different behavioral aspect is ranking in fashion. So just to abbreviate this part here is like ranking in Amazon fashion presents several unique challenges due to large and varied product catalog. Users with diverse fashion preferences and business requirements to make the store appear fashionable and fresh. We found that optimizing for individual targets, such as click add to cart, which we know that the algorithm plays a massive role in terms of add to cart is a big role, but not necessarily as much in fashion or on purchase. So it does not achieve the desired outcome. For example, while customers tend to purchase discounted items, they're often browse and click on the items that are high-end fashion. So we discovered that optimizing for a fused target that combines purchases with clicks often satisfies user information need better in the fashion store. So they're looking at a different way. So it's not just when it comes on the fashion side, it's less so about add to cart as a lead signal. They're talking about fused target, which is a combination of purchases and clicks and less to do with add to cart. So it was kind of geeky there to try and cover a lot of information. Again, there's stuff there can pick apart. I'd like to do a show which breaks down the hunger score to be a bit more clearer. I mean, the feedback I've been getting is pretty good in terms of these shows that I'm doing. I know some of this content is quite heavy, but let's be honest, if you're selling on Amazon and you don't know the real truth behind A9, you'd be a fool not to pay attention to it because it's your bread and butter. You don't have to get into the absolute depths of the technical stuff, but the information is out there. And as I've said before, it's like I see this as kind of open source. Whether this ends up in courses or not, I don't know. Maybe it's not sexy enough to be in the courses because it's not like swinging the carrot, we'll take you to the top, baby, we'll make you loads of money and you only have to spend 10 minutes on it. But on the flip side, just having some really good grounding in this stuff, spending a little bit of time absorbing this information is going to make it a lot easier when it comes to optimizing your listings and understanding these things, because when we're looking to solve issues with our listings, we can blame it all on an A9 update, but if we're clueless about what we're talking about and have no idea, that isn't going to help solve the problem. It allows us to partition the blame to just blame the update, but it doesn't solve the problem. So trying to understand this stuff in a bit more clarity is really important. So hopefully there's some bits there, even if you have to go back and re-listen again, there should be plenty of information there to understand that when a big update comes along, how the update happens and what they're doing in the background in terms of training sets. So it gives you a bit more clarity to understand, because especially if they've rolled something out, what we kind of often see is that when a rollout happens, there's a pullback as well. If it's a completely messy rollout and we're seeing that products are, with no reviews or at number one in high velocity markets and stuff, normally the adjustment and the shuffle comes 2 or 3 days later, sometimes quicker. So they pushed out a data set, didn't work, they pull back. So that also helps getting away with the point of consistency, understanding with that going on, in 2 or 3 days time, instead of panicking, why is my keywords dropped and everything else? Because it could be down to a number of reasons as well. I want to do some more advanced stuff on the geo ranking side, because again, when someone might turn around and say there's an A9 update because they've had a drop in rankings, maybe it's because, you're used to seeing your ranking through one lens. So all these third-party tools, they're not using geo-ranking. They're not using 400 plus postcodes where it will show you that a chunk of them may be number 1, number 2, but can go up to about number 300 or so. So you might find that when you're looking and searching under your jurisdiction, that your ranking is in the right position. Yeah, that looks right. But what about across all the other zip codes? And if you was to average that out, would that match up as well? So there's a lot of stuff there to kind of unpick. The only problem with that is that the big software companies can't afford to really do geo ranking stuff at this stage. And the reason behind that is the amount of processing power they need in order to do that across all the keywords. So hope you enjoyed today. Sharon will be back here tomorrow. Isabella back on Monday. I'll see you Tuesday and Wednesday next week. Take care and take care of your family. Much love, and I'll see you soon.